Hi everyone, welcome to OpenJS World 2022. This is a talk on publishing in JavaScript ecosystem, how to keep everyone happy. My name is Trivikram Kamat and I am a software development engineer with AWS. My Twitter username is Trivikram and my GitHub username is Trivikr. Before we start the meeting, we'll have a reality check. You cannot make everyone happy in life as well as in tech. But you can try your best. So let's try our best. If you're active on social media, then please use hashtag OpenJSWorld22. You can also use hashtag JavaScript, hashtag Node.js, and hashtag NPM. Don't use too many hashtags, else Twitter might think you are a bot. So why talk about publishing? It's because JavaScript ecosystem is very complex. If you're supporting browser, that is Chrome, Firefox, Edge, Safari, or your favorite browser. For server runtimes, that is Node.js, Deno, Cloudflare workers, and more may come. For JS native, that is ReactNative, NativeScript, Flutter, Ionic. There are several module formats like CJS, ESM, AMD, UMD. Then the sizes, there is publish size, there is install size, there is bundle size. And then we have types. So if you're using Flow, TypeScript, or a superset of JavaScript, you have to provide types. Then if you're using a superset of JavaScript, you have to provide sources or source maps for debugging. And then comes observability, that is open telemetry, open tracing, open sensors, etc. My Twitter username is visible in the left bottom of all the sites. Feel free to tweet at me, DM me if something needs to be corrected or if I missed anything. Since this talk is in recorded video format, feel free to jump to the section you are interested in. So let's start. What are we going to cover? So we'll cover what criteria will affect your package from the previous slide. We'll evaluate why, how, and what of each criteria with some approximations based on data. Note that suggestions are based on assumption that you maintain a package on npm using package.json. We will mention Deno first packages on one slide if you want to give them a try. So let's start. So which criteria will affect you? And the answer is, it depends. Software engineers have a love-hate relationship with these two words. As you would have expected, I would be saying them often in this talk. So it depends on what or how of the problem solved by your package and where or how do users want to use it. So let's answer the first question. Where or how do users want to use that package? To find this answer, ask them. It's that easy. And if your package is popular, they will tell you. You can also populate this data in telemetry if your package supports telemetry. So let's see the published criteria. So we'll look at why, how, and what of all these criteria. So first criteria is browser. So why does your package need to support a browser? Because JavaScript is the language used for scripting in the browsers. Well, some of you might say WebAssembly allows running non-JavaScript code on the browsers. That's true, but it's likely to be used for very specific cases like compute-intensive apps. JavaScript is still relevant. So let's see how you can support browsers. So if you have some browser-specific code, then use browser field in your package.json file. So in that field, you can tell where the main entry point for your browser is, or you can also tell whether you have alternatives like for module A. There is no browser equivalent, you can say false. For module B, if you have specific shim, you can provide that link, or for specific file, you can tell the browser alternatives. Now, next question will be, what browsers to support? Isn't JavaScript support fragmented on browsers? Yes, but Internet Explorer is retiring on June 15, 2022. Retiring. And Safari is also likely getting competitive. EU is drafting an act to allow non-WebKit JavaScript engines on iOS, and Safari team is hiring. So it's all good news. So if you want to support browsers, you can support only modern browsers, that is ES6 plus. Now let's see the next criteria, this server. So why do you have to support server runtimes? So Node.js is among the most popular server runtime, not in JavaScript. It is one of the most popular server runtimes. And Deno is being used in more products. Do check out the showcase linked below. And Cloudflare Workers is also popular and it's going open source. Now your question would be, fragmentation existed for years in the browser. Is it bad that now we are having competing server runtimes? Answer is no. The reason being, there is a web interoperable runtimes community group which is collaborating on API interoperability of web platform APIs across runtimes. Check out wintercg.org. It has members from Node.js, Deno, and Cloudflare workers. Don't see it as a competition, see it as a collaboration. For example, Deno added a test runner, and then Node.js added an experimental support for test runner. Cloudflare workers made themselves strictly compatible with web. Node.js is following. Node.js proved that JavaScript can be run on the server side, and then Cloudflare workers and Deno followed. So how do you support Node.js? Just add file path to the main entry of package.json. That's it. How do you support Deno? So Deno has an experimental node compatibility mode, but it doesn't support all modules of Node and it supports only JavaScript, but you can give it a try. If you have a lot of users on Deno, then you can use DNT and publish your Deno first package, Deno first module on NPM. How do you support Cloudflare workers? The good news is that any Node.js package that uses Webpack or any other polyfill bundler runs in Cloudflare workers. So what server runtime to support? And the answer is, as you guess it right, it depends. Support the server runtimes your users want. And since Node.js is very popular, the users will likely need it to be supported. The next criteria is JS native. In JS native, you write JavaScript code, but the UI framework creates native apps. Now, what are the benefits of JS native? So there are progressive web apps, but they have limitations like lack of push notifications. JS native helps you fix that. JavaScript native frameworks had performance trade-off like 4-5 years ago, but now it has reduced significantly. Do check out the linked blog post. So how do you support JS native? In React Native, if you have to write some React Native specific code, you can use .native.js or .native.ts extension. In case of NativeScript or Flutter Ionic, I could find out how to write platform-specific JavaScript code, but do check out their documents linked below. So, what JS native frameworks to support in your package? It all depends. Yeah, support the native frameworks your users want. Now let's look at the module formats. So modules are building blocks of software. Module format is a syntax used to define a module. When JavaScript was getting popular in early 2000s, there was no standard module format. So multiple module formats were developed and they are used in parallel. Before we go into module format, just a warning. Conversations might get heated because of opinions when we talk about module systems. So just take suggestions with a grain of salt. So let's see what are the module systems we have. So first one is ESM, which is ECMAScript. It's an official standard format, full stop. Then we have CJS, also known as CommonJS. It's the original module format in Node.js. Then there is AMD, asynchronous module definition. It was specifically made for front end. And there was UMD, universal module definition, was specifically made to work universally. Now ESM and CJS are the most popular formats right now, so we'll talk about them. So how do you support module formats? If you're supporting a single module system, then add the file path in the main entry. So in this case, your main entry says the code is in dist main.js. But if you want to support both CommonJS ESM, then you can use conditional exports. So in this conditional exports, you tell that if for ESM application, import from dist main.js, and for CommonJS application, when you're requiring a dependency, require it from dist main.cjs. For supporting CJS on ESM, you can also use an ESM module wrapper. That is, you can write your code in CommonJS. So in this case, you have a file called index.cjs, which exports a name, which has a value. And you can import it from MJS file, which imports CJS module and re-exports it. You don't have to do this manually. It can be automated by Gen ESM wrapper npm module. So we come to question, which module formats we should support? Ideally, you should only support ESM. Hear me out. Ideally, you should only support ESM. But that would break the users on Node.js whose application code is in CommonJS format because you cannot require a ESM package. So be a good citizen of JavaScript ecosystem and support both CJS and ESM if you have to support Node.js. Now let's go to the next criteria. What are the sizes? Why are the sizes important? So there are three types of sizes. First is publish size, that is size of the package being published. Then comes install size, that is size of the node modules folder when your package is added as a dependency. And third is bundle size, that is size of the file generated when a bundler is used on the application code which uses your package. So let's see why sizes are important. So if publish or install size is small, the installs for your package will be faster. Also, your package will have smaller carbon footprint. Then adding your package will not exceed size limits in resource constrained environments like serverless. Lambda, for example, has application size limit of 250 MB. And if your bundle size is small, the load times for the final application will be faster. So let's see how you can reduce publish size. So to reduce publish size, write minimal code needed for solving the problem. That's it. Just write the code to solve the problem. Yeah. And use package.json files field to only publish required files, thus removing unnecessary files. You don't need to publish like tsconfig or eslint, for example. If using TypeScript, more types you definitely type. TypeScript users will likely complain saying that your package is not providing first-class support, but if reducing install size is a requirement for you, more types to definitely type. Also, if you're using TypeScript, publish sources and source maps in a debug variant of your package using disk tags. So when somebody installs the default variant, they will not get sources and source maps. Next, let's see how we can reduce install size. It's super easy. Have minimal or no dependencies. This will not only reduce your install size, but will make your application slightly more secure. You can also share tips on reducing publish or install size with the packages you depend on. You can also consider providing a variant of your package just for resource-constrained environment using a disk tag or suffix. So let's see how you can reduce bundle size. So make your package reshakable, that is dead code elimination. Use named exports so that your users can import those named exports. Then publish ESM version of your package because reshaking is easy with ESM package. Then make your packages side effects free. You can split your code into multiple smaller modules. You can check the link from Webpack website, which explains how reshaking works. Now let's see what sizes you should worry about. And the answer is, it depends. You guess it right. But it's always good to have small install, publish, or bundle sizes. So let's see why types are needed. So JavaScript is a dynamically typed programming language. That means the types are checked and errors are spotted only at runtime. But between 15 to 38% of the bugs can be prevented by types. There are links below. So using types, IDEs can also provide code editing features like code completion and parameter information. Those are the benefits of types. So what kind of typed JavaScript languages you can use? So TypeScript is the most popular type system for JavaScript. You can check state of the JavaScript survey, or you can check NPM trends. So we'll just talk about TypeScript. By the way, there is an ECMAScript proposal for type annotations. So at some point in future, hopefully we can just provide types annotations and get the same benefits which TypeScript provides. So how do you support types? So either write your code in TypeScript or generate types from comments from your JavaScript code by running TypeScript compiler. I personally have been writing code in TypeScript for 5 years now, and I highly recommend it for most applications. So find answer for your application. The types created can be linked in the types field in package.json. That is, you say types this types.d.ts. Or you can even submit them to definitely type to be published under types organization npm. So how to decide whether you have to support types? And the answer is, of course, it depends. But your users will most definitely need TypeScript types. So if you support them by default, they will be happy. Now let's see the next criteria, debugging. So if your package code is in a language which compiles to JavaScript, like TypeScript, then you need to publish source code and source maps to help with debugging. So it helps your users to debug through readable code. It improves their understanding of your package, helping them unblock themselves and cut relevant bug reports or feature requests. If your sources or source maps are not present, your users have to debug through the transpile code which or minimize code, which is not that readable. So how do you support debugging? So in case you're using TypeScript, you can enable generation of source map files in your TypeScript config, either by setting source map to true or inline source map to true. Source map to true will create the source map files. Inline source map will just inline those source map files. Similarly, you can include TypeScript source in your source maps. If you say source root is equal to src, that will link source map to source root folder, or you can do inline source is equal to true, that will copy the source files in the source map. So let's see what you need to support. So if your package code is in language which compiles to JavaScript, do provide solution source maps. And if it cuts into your install publish size quota, you can release a debug variant using debug distract or suffix. Next, let's see the criteria for observability. So observability is the ability to measure a system's current state based on the data it generates, such as logs, metrics, or traces. Observability helps developers build better, stable applications. Back in mid-2010s, there were competing APIs like OpenTracing and OpenCensus. Luckily, in 2019, they got merged into OpenTelemetry. So how do you support OpenTelemetry? So you can add either out-of-the-box support for OpenTelemetry or add instrumentation in external package. And this is an example of how it works. So import trace from OpenTelemetry API, and then you create a tracer with the name and version, and then you create a span using the tracer, and you do some work, and then you end that span. Do check the OpenTelemetry docs on how this works. They have additional documentation on how you can add metrics and logging. So how do you support or what do you do for observability? So you add an external instrumentation for your package, either in your NPM scope or in OpenTelemetry. So if you're using your scope, then you can use scope name and slash OpenTelemetry instrumentation. But if you're contributing stream to OpenTelemetry, you can contribute to OpenTelemetry instrumentation package name. So let's come to conclusion. This is opinionated. So just take it with a grain of salt. So in case of browsers, support only modern browsers, that is ES6 Plus. For server, be Node.js native and add support for Deno or Cloudflare workers if your users need it. For JS native, it depends whether your users need it. ReactNative supports platform-specific code. For module format, support dual packaging, that is CJS plus ESM. You can optionally also publish ESM only variant of your package. For sizes, it depends, but aim for smaller publish install bundle sizes. Your users will thank you. For types, at least publish TypeScript types. You may write your code in TypeScript. For debugging, provide sources and source maps in debug variant. And for observability, provide an instrumentation package which supports OpenTelemetry. So thank you for listening. My name is Trivikram Kamat. My Twitter username is Trivikram and GitHub is Trivikr. I'm pretty active on Twitter, so do tweet at me or send direct message if you have any questions or suggestions. And you can access the slides at slides.com Trivikram OpenJS Publishing. Thank you.